Good morning, students. Today we are studying about the units 9 resultant force. Okay, if you have any doubts, please do the chat to explain your or asking questions through the chat. Okay. First of all, we must know about the concept of resultant force. Before going to the concept of resultant force, we must recall what is force. So what is force? It means the pushing or pulling an object is known as force. I think this unit also was studied in the unit 4. And the SI unit of force is Newton. And the measuring equipment, the force measured SI unit is Newton, capital N. Then the measuring equipment is Newton spring balance or Newton balance. This is the pre-knowledge we are observed, we are listening to here. Now, going to know about what is resultant force, the concept of resultant force. In here, the figure, three figures are chosen here. This is first and second and third. These figures are what is explained. The first figure shows the one person pushing a car, and the second figure shows two persons are pushing a car, and third figure shows the three persons pushing the car. So what do you understand the figures to, or these actions show these figures to you? So first figure shows one person pushing car, but car can't move. And second person, instead here the two persons are pushing the car does not move. The third figure shows the three persons pushing the car just start to move. So what is show it? In here, the concept of what is concept of resultant force. It means, first of all, you should know about what is the concept of resultant force. So, what is resultant force? The single force, three persons are pulling the car. First figure shows the one person pushing the car, and second figure shows the two persons pushing the cars, and third figure shows the three persons are pushing the car. So, the single force acting in many forces. The single force acting in the single force acting in the place of the many forces, the single force that gives the same result as many forces is known as resultant force. So now we are going with the first figure. In here we consider one person apply the force is considered as F. In here, and second figure shows two person apply the force is considered. Here is one person also for F and other person also F. So the resultant force in here 2F. In here, you are consider all the persons are give same amount of forces. In here, F, F, F. Three persons are give F, F, F. So total force 3F. So now we are going to move the concept of what is resultant force. Repeatedly. When more than one force is applied, when more than one force is applied, when more than one force is applied, in second figure, observe the second figure. When more than one force is applied, the single force that gives the same result as the single force. I give the single force as the same result as the single force with the same result as that of all the contributing forces known as the resultant force of individual contributing forces. Now, going to know about the concept of classify the resultant force in your session, in your studying sessions. The resultant force in your unit, students, the resultant force resultant force in your sessions can be classified into first two ways. One is collinear, the result of two collinear forces. The first one is result of two collinear forces, and second one is the result of two parallel forces. Okay, students. The resultant force can be classified in two ways. The first one is result of two collinear forces, and second one is result of two parallel forces. Right? Then the result of two collinear forces can be classified into two ways in your session you are studying. In here, the result of two collinear forces acting along the same direction. Acting along the same direction. Acting along same direction. And second one you are studied about result of two collinear forces acting along opposite direction. Acting along opposite direction. Okay, students. First of all, we must know about the concept. What is resultant force? When more than one force is applied, the single force that gives the same result as that of all the contributing forces is known as the resultant force of the individual contributing forces. Then you are studying about in your unit, you are classified the resultant force can be classified in two ways. One is the result of two collinear forces and second one is the result of two parallel forces. What is the main difference between the result of two collinear forces and result of two parallel forces? The main difference is the result of two collinear forces having same line of action. The result of two parallel forces having parallel, the first difference between them having parallel, and second one different line of action. You should know about the difference between the result of two collinear forces and result of two parallel forces. The result of two collinear forces, the main difference, they having the same line of the action, and the result of two parallel forces, main difference is the first one, it is having parallel and but different line of action. So when asked some of the question, I have asked for you, write two difference between the result of two collinear forces and result of two parallel forces. So you write down. Now start your answer is like that. Having the first difference between the should we write the difference result of two collinear forces. Two collinear forces, result of parallel forces. Write down the difference like that way. Result of two collinear forces result of parallel forces. So the first main difference, having parallel, not having parallel, note it students, it's important, having parallel. In here, have not, haven't parallel. And second difference, same line of actions, having same line of action. Different line of action. Here students, this is the main difference between the result of two collinear forces and result of two parallel forces. Okay. Now we are going to study about the first classification of result of two collinear forces. In the result of two collinear forces can be classified into two ways. Result of two collinear forces can be classified into two ways. One is result of two collinear forces acting along the same direction, and second one acting along the opposite direction. Okay, then we must know about the examples of the result of two collinear forces acting along the same direction. This is the examples of result of two collinear forces acting along the same direction. The first one, a group of pupils pushing the car. Second one, a group of people pushing the fishing net. These are the examples for the result of two collinear forces acting along the same direction. Now students, we are going to investigate the result of two collinear forces acting along the same direction. Investigate through the activity to investigate or finding out the result of two collinear forces acting along the same direction through this one of the activities. This is the figure shows. This figure shows the activity here. So now we are going to discuss with the concept of method. First of all, placed the trolley on the table and fix the ring to one side. This is the trolley, students, imagine it. This is the trolley. This is the trolley. And then place the trolley on the table and fix the ring to one side of the trolley and attach the two strong strings to the rings. Right, this is the string and attach the two strings. Then place the two strings over the two pulleys and connect it to the Newton balance B and Z. Right, now we are going to name as Newton balance B and C. And this is the Newton balance A. So fix the other end of the trolley to the wall through the third Newton balance. Right, this is the third Newton balance. Record the readings of the balancers. Now we are going to record the readings. Then we take the reading from the B and C. You can observe the relationship between the B, C, A. Now we observe the relationship between the B, C, A. So in here, when applying the different forces from the BC and applying the different forces in the BC and observe the relationship between the balance A. You can notice one of the tables shows the relationship between the BC. You can find out the relationship, students. Right? So the first one, the table shows balance B read 6 Newton and balance C 6 Newton, then balance A 12. Balance B 3 Newton, balance C 4 Newton and balance A 7. And balance B 8 Newton and balance C 6 Newton, balance A 4. Now we are going to find out the relationship between the BCA. So through this activity, we take conclusions. The main conclusions, you can notice the balance B, balance C, 6 plus 6, 12. And the balance 3 plus 4, 7. So through this way, take a conclusion. The first conclusion is balance B, reading of balance B plus balance C, that is equal to balance A. Okay, students, this is the main conclusions from this activity. Through these conclusions, we take one of the main other conclusion is that is when two collinear forces when two collinear forces act along the same directions, the result of the two forces is equal to the sum of the two individual forces with the directions in the direction of the force. When two forces acting in the same direction, so B and C consider, and the resultant force is the sum of the two forces. Sum of the two forces, such as when two forces acting in the same direction. For example, X Newton and Y Newton, which are acting in the same direction. The resultant force shows the individual force. So that is equal to the sum of the two pulling forces. Sorry, two forces. Right. Forces acting in the X Newton and other forces also acting in Y Newton. So the resultant force is explained the sum of the two forces. So what is the resultant force in here? What is the resultant force? The common equation R is equal to X Newton plus Y Newton. Newton is the SI unit of the force. So you can easily to find out the resultant force like that way. Right, students? This is the one of the question for you. You can find out the answer. This question, read it and find out the answer. The time for you. Please quickly find out the answer and give the chat to. Give the chat me and find out the answer and chat with me. Quickly chat. Chat with the answer. Dariga, change your unit. Dariga, change your unit. Newton, it's a capital. Should we know about it? I think easy questions, but like that way, mirrors, you are do it. Right, students. So I think you can find out the answer. First of all, read the question first. Two children are pulling a thread. Two children are pulling a thread. Two children are pulling a thread. So now, read the question. Make an imaginary figure. Two children are pulling a thread connected to a box. So this is imaginary box and placed on the table. It is placed on the table. When you read the questions, first you put a figure like that in the same direction. In the same direction. How many children? Two children. So the force is applied by one child is 8 Newton. So one child 8 Newton. While the other child is 6 Newton. Other one 6 Newton. Question: what is the resultant force with which the children are pulling the box? Question, what is the resultant force? That is the question for you. Okay, so what's the resultant force is? In here, the resultant force find out 8 Newton plus 6 Newton because the two forces are acting the same direction. So same direction, when the two forces or two or more forces acting in the same direction should be added or should be summed. 8 Newton plus 6 Newton, that is equal to 14 Newton, and should be denoted the direction also because the resultant force also vector quantity. Vector quantity has magnitude and direction. Okay, students? Should we know about it? It's also one of the main concept for you. Right. Okay, can I move to result of two collinear forces acting along the opposite direction? This is the another type of resultant force. So, one of the example, the figure shows the one of the example. Result of two collinear forces acting along the opposite direction. This is the one of the example is pulling a rope. This is the one of the example for it, pulling a rope. Right. And second one, your school book also have the figure. Here it does not show it. It does not show it. So please find out that. This is the figure of it. This is trolley. First of all, place a trolley on the table and then fix a thread through the pulley and hang a spring balance. So like that way. Right. Question for you. You are considered one of the smooth pulley because why here they give the smooth pulleys because here avoid the frictional force, to avoid the frictional force. Right, students? Now, first of all, this figure shows or this activity shows first method. Place the trolley on the table. Okay, place the trolley on the table and fix two pieces of string to the two ends of the trolley. Ends of the trolley, fix two spring balance or strings. Allow the other ends of the pieces of strings to pass over the two pulleys and attach to two Newton balances A and B. This is named as A and this is named as B. Now students, do three activities. First, three activities. The first activity is record your observation on the motion according to the motions. Right. Record the motions. Here the 44 Newton applied. Here also 4 Newton applied. Here also 4 Newton applied. So in the both ends are applied 4 Newton and 4 Newton. What is the observation? The resultant force is opposite direction. Here also 4 Newton, here also 4 Newton. So the resultant force opposite. When the force is acting in 4 Newton, the resultant force is 0. Resultant force is 0 because same forces are acting along the opposite direction, but it has same line of action also. And second activity, so trolley does not move. The first activity to trolley does not move. In the second activity, in the 4 Newton force in the balance A, 4 Newton force in the balance A, and 6 Newton force acting along the balance B. So the trolley moves towards the B balance. Trolley moves towards the B balance because the resultant force in B. How to find out the resultant force in here? From the when the forces are acting in the opposite direction, you should consider in which side have the higher force acting, that side to other sides you should subtract. So example, here forces act from, in here forces act 7 Newton, in here forces act 2 Newton. So what is the resultant force? When the forces are acting on the opposite side, so the resultant force is 7 Newton minus 2 Newton, that is equal to 5 Newton. Subtract from the higher value to lower value and mention the directions. In which directions, which side has a higher value, you should mention the directions of the higher value direction. So in here, 6 Newton minus 4 Newton, that is equal to 2 Newton, and the direction should be mentioned, trolley move towards the B direction. And the third activity also, in the both sides acting in the balance A and balance B acting same, 6 Newton and 6 Newton. In this condition, the resultant force 0. So trolley does not move. Trolley does not move. Okay, students, can you understand about it? This is the situation and observation and reasons. So the first applying 4 Newton forces in the equivalence, the trolley does not move. The trolley remains under the equilibrium under the actions of two equal forces acting in the opposite direction. The two equal forces acting in the opposite direction, 4 Newton and 4 Newton. Then applying a 4 Newton on the balance A and balance and the 6 Newton forces in the balance B. So the trolley moves in the direction of the balance towards the balance B. Because there are two unequal forces. Reason is should be find out the two unequal forces acting on the trolley in the opposite direction, and the trolley moves in the direction of the larger force. And second one, apply 6 Newton force on the balance B and 6 Newton force in the balance A. So trolley does not move because the resultant force is 0. The two forces acting in the opposite directions are equal. Through this way, to the conclusions, when two collinear forces are exerted on an object in opposite direction, the resultant is given by the difference between the direction in the direction of the larger force. Okay, I already explained, students. The resultant forces acting in the opposite direction, 7 Newton and 3 Newton. In here, the resultant force is calculated from the subtract from the larger value to lower value. So larger values is 7 Newton and lower value is 3 Newton. So that is equal to 4 Newtons. You should mention, because it is a vector quantity, so should be mentioned the directions also. In the larger value directions, you should mention the direction, students. Through the arrow mark to mention the direction. Now, this is the question, students. What is the magnitude and the direction of the resultant force of 6 Newton pulling an object? Right, consider an object, 6 Newton pulling an object placed on the table in a certain direction, and another force 4 Newton pulling it in the opposite direction. Right, opposite direction acting 4 Newton. So what is the resultant force, students? 6. From the resultant force is R is equal to 4 minus from the higher value to subtract from higher value to lower value. So 6 minus 4, that is equal to 2 Newton. Then should be mention the direction. What is the result direction in 6 Newton side? Okay, yeah? Right. Resultant force of two parallel forces. Result of two parallel forces in here. You should know about when two forces acting along the same direction, the result of the sum of the two forces. I already explained. Right. Result of two collinear forces, students. In here, result of two collinear forces like that way. X Newton and Y Newton forces acting on it here. X Newton and Y Newton forces acting on here. What is the resultant force? So in this situation, the resultant forces should be added or sum. So the resultant force is X Newton plus Y Newton. x plus y. So totally x plus y Newton gives the resultant force is x plus y. So in order to find the result of two parallel forces acting along the same direction, the two forces should be added. The two forces should be added. Must be added. Right. So one of the questions given for you. Students, sometimes you can't continue to finish this session. Please all are be connected with me because some questions also I have. Do it through the way we can complete it to finish this session. So please, if you say okay, please through. Then the part. Result of two parallel forces. Right. I think in your book, open your book and find out the 160 page. One of the activity does not show it here. One of the activity does not show it here. So please open your book and find out the, now we are discussed with the activity. The activity 3, this activity explain. This activity explain. This activity. In this activity, students, now we are know about in this activity, you should consider first of all, take a strip of wood and make a holes in the 3 points, and center call is named as in here Z and ZA. Then another point, the distance between the ZA, this is named as 3 holes are here, right? This is A, this is B. The distance between the ZA and ZB should be equal, the first one, and second one, attach the spring balance in the hole A and the hole B. This is the spring balance, imagine it. In the set points, attach another spring balance, C. And how to pull the 3 balances keeping the strip of wood in the rest position. Always keep the strip perpendicular to the Newton balance. You may need it to apply equal forces on it. So one of the question in here, in the balance A and balance B, you should apply equal forces. Equal forces should be applied. Why? What is the reason equal forces applied in here? What is the reason? The reason is the strip perpendicular. Keep the strip. The reason for it, they keep the strip perpendicular to the Newton balance. Keep the strip perpendicular Newton balance. Mostly like that questions are asking in the question paper to you. To the Newton balance, please note it, students. This question mostly asking. First, repeatedly I say about what are the conditions. First, this figure shows to ask what is the aim of this activity. So the aim is to find out the resultant of two parallel forces. Two parallel forces are equal to their sum. This is the aim of this activity. Then, when you arrange this practical, what are the facts should be considered? This is another question for you. In here, the distance between the set A and the set B equal, the first condition. And second condition, applying equal amount of forces in the balance A and the balance B. And third question for you, why did you apply equal forces in the balance A and balance B? Why? What is the reason? Because keep the strip perpendicular to the, keep the strip perpendicular to the Newton balance. Keep the strip perpendicular to the Newton balance.
So we must apply equal amount of forces in the balance A and balance B. Then what is the observation you got through this activity? What is the observation you got? The observation or reading of this activity is C is equal to balance C, the balance, reading of the balance C is equal to balance A plus balance B. Balance A plus balance B. This is the reading of this activity. Right. So through this activity, what is the conclusions can be arrived? So the answer is to find the result of two parallel forces. The result of two parallel forces, balance A plus balance B, balance A plus balance B, two parallel forces acting along the same direction. Here also, same directions. The same direction, the two forces must be, the resultant force is, here the resultant force C. That is, the two forces must be added. What is the two forces? Forces A and force B. So force A and force B should be added in here. Right, our students? Can you know about this practical is essential for you, because most of the time asking like that question for you. Okay, so another question for you. One of the best uses we can get from the knowledge of resultant force. What is the beneficial of resultant force? That is the last question for you related this session. What is the beneficial of resultant force is? The beneficial is to make use of large number of small forces in place of single large force effectively. In the large object, we use the small forces to, we use many numbers of the small forces can be expressed as one of the individual forces can be expressed to say easy to carry out or do this work. So this is the main beneficial of the resultant force. Then next one, last one, result of two, last one, result of two inclined forces. Result of two inclined forces. In here, result of two, how to find out the result of two inclined forces? First of all, the forces are not parallel to not parallel. And second one, how to find out the resultant force when acting in here, in which sometimes P Newton and Q Newton. So P greater than Q. The condition is P greater than Q. So the resultant force towards the P Newton. The resultant force towards the P Newton. So two forces P and Q that act in their lines of actions inclined to one another, not parallel, inclined to one another is, that's a figure shows in here. So when two such forces are applied on an object, the object does not move in the either of the direction of P or Q. P or Q. In such instance, the direction of the motion of the object lies between the PQ. The directions of the motion of the object between the P and Q. This is the main condition of the result of two inclined forces. Right, students? Please do the miscellaneous exercise question number 5 quickly. Find out write down the answer in your book. Take your book, students. Do these questions. Question number 5. If a trolley is being pulled by two forces, one with magnitude of 20 Newton along the east and other with magnitude of 15 Newton along the west, in which direction would it move and what is the result? This is the question for you. Quickly find out the answer and through the chat to answer to me. Give your answer through the chat. Question bank. answers. Large size question. Students, this is the question time for you. So now you are ready to do this question. These are the question. Please completely. Quickly find out the answer and chat with me through the answer. Chat the answer through the. Chat your answer quickly. And second question, students, if you completed first question, continue to second question.